So let's talk about the hardware first. So here is the project while it has still development. So you can see here, so this is one station here, right here, and this is a second one here. So these are supposed to be at two different places in two different users' home. So let's talk about the hardware. So this is a TFT touchscreen that I bought from Adafruit. So Adafruit is an American company that makes very good hardware for people who are making Arduino projects. So this is a quite high resolution screen actually, and there is this circuit. So basically you can think of it as a graphics card for this TFT screen, and it's manufactured by Adafruit too, so it's designed to work with this screen. So a first issue I had on this project is that in fact this circuit uses a protocol which is called SPI, and the problem is that if you take an Arduino Wi-Fi like this, which has an integrated Wi-Fi chip, actually this Wi-Fi chip uses the same bus as SPI. So when you connect the TFT screen, it's actually going to use the same bus. So and there is a problem, which is that this circuit here does not support sharing the bus with other hardware. So basically when you connect this chip to the Arduino, what happens is that if you connect it to a Wi-Fi Arduino, the Wi-Fi chip stops working. So when I realized this, I realized that I would have to use two Arduinos in each station. So this is why you have a first Arduino here, which is an Arduino Uno without a Wi-Fi chip. And there you have the Wi-Fi Arduino with its chip, but which is not connected to the TFT screen. So it actually made the project more complex because I needed these two Arduinos, and I needed to design a communication protocol between them. So we are going to talk about that later in the video. Originally, I also bought this circuit, which is supposed to help with the quality of touch data. So it basically converts the analog data input here to digital data. But it's a feature that actually the RA8875 can also do. So what you can do is that you can connect the analog input to this circuit, because it also gives the raw analog input, and then you get the digital output here. But what I found in practice is that the data you get from this circuit is much less precise compared to the data you already get with this one. So there was really no point for me to use this one. And actually, since I ordered it, Adafruit has retired it. So maybe they realized it was not so useful after all. But even though I use the touch data generated by this circuit, which is much more precise, there are still some issues and the data is not perfect. And a big issue is actually that you sometimes get random absurd values which are completely incorrect. So you just get sometimes some points which are at the opposite of the screen. So I had to do something to solve this issue. So let's say that we are drawing a line, and let's make a diagram to explain better what happens. So of course it's not on scale because the distance between the points is very small, just a few pixels in reality. So what happens that you get, let's say, a first point, then you get a second point, and then we are unlucky and the first point is actually an incorrect value and it's very far away. So what we do is that every time we have 3 points, we compare the distances between these 3 points. So we compare this distance to this one and to this one. So what we can see here is that the distance between these 2 points is shorter. So what we are going to do is that we are going to ignore the third point, and we are going to average the two values, and the orange value here is the one we are going to use. So we average the two nearest points. And then when we get a fourth point, we do the same, but with the 3 last points. So in fact, we don't lose many events. We just need basically 2 points in the beginning to initialize it, but then we do this moving average thing where we ignore the furthest point for every 3 values. So this allows to get rid completely of these artifactual values, and we get a high precision because, as you can see, we can draw things very, very precisely, and we don't get any value out of line. But since we get a value every 6 milliseconds, this is a lot of data. And actually, this is a bit too much. So I have actually reduced the sampling to only 20 milliseconds. So I did a few benchmarks to see if it would degrade the quality to use 6 milliseconds, 10, 20, 50, 100. So you can see that if we use only 100, it's very, very bad. You cannot draw something very smooth. So I discovered that the good compromise is 20 milliseconds. As it doesn't degrade the quality, actually it improves it a little because it allows to remove some artifactual random variation around the points. So you get actually something smoother by just drawing a line point every 20 milliseconds. So what it means is that only every 20 milliseconds we consider that we have a new point, and we are going then to draw a line between the previous point and the new point. Finally, I discovered the last issue, which is that at night the touch data is very, very bad. So originally I didn't understand what was going on, and after that I finally understood. It's actually because I use a light sensor here to detect the level of ambient light, and I reduce the brightness of the screen according to the ambient light. And for instance here this screen is at 50%, so the screens appear to flicker, but it's because of the camera. In reality it doesn't flicker at all, it's just darker. And if you look at what happened, you see that the data is not very good, and there are a lot of spikes like this that appear. While if I do that on a screen that is at 100% brightness, there is no problem at all. So I think I finally understand what is going on. I think it's because the adjustment of the screen brightness is based on PWM. So you may to explain how it works. So PWM is a technique that you can use to change continuously the voltage of a signal. So when the screen is at 100%, you don't need PWM at all. You just use, let's say, 5 volts, and the signal is constant. But when you want, let's say, half the brightness, you could, in theory, output a voltage of 2.5 volts. But it doesn't work like that. Instead, it uses PWM. So what it does is that it produces a signal like this, which alternates between 0 and 5 volts. And the idea is that it alternates very fast, so on average this corresponds to a level of 2.5 volts. But it really is not at 2.5 volts, it's really a square signal like that, and as humans we cannot really see the difference. Actually it appears to flicker on the camera because in that case we can see the variations, but the point is that this signal, this alternating signal, I think is created an interference with the analog touch data that is transmitted in a wire which is close to this wire. So to solve this issue, what I did is simply to put the brightness at 100% whenever the user is drawing something, and then after a few minutes it goes in a sort of a sleep mode in which the brightness is again adjusted according to the ambient light level.